This is a debriefing on the rock cycle game. I don't deduct points for wrong answers if your answers show that you were thinking, so I want to go over some important points brought out by the rock cycle game and be sure those are clear. Plus, you'll get to meet a new type of limestone. One important idea is that the rock cycle has been active since Earth became Earth, and it's still active today. And one beauty of this is, that with processes still active, they can help us decipher the past. And the past can help us understand what we see today also. For example, if you found this rock made up of tiny spheres cemented together, you might wonder how that came to be. Perhaps you visit a beach in Australia later on and see waves rolling around similar spheres on the seafloor near the beach. And you have an idea, and do some investigating, and come to the conclusion that where this rock was formed must have been in a beach environment. I've zoomed in on that rock so you can see these little spheres more clearly. Some look like spheres, and some have been cracked or eroded, and you can see that they have little dots inside, nuclei. So this is what happens to make this oolitic limestone, is that on a seafloor where there's a lot of calcium carbonate in the water, and there's warm conditions where the sun is warming the water, calcium carbonate precipitates. It turns into very easily. And at the beach there are sand grains, and tiny sand grains can roll and pick up layers of the calcium carbonate. So like rolling a snowball, you end up with little nuclei here, nucleus here, and then layers of calcium carbonate around the outside. And this isn't limited to Australia. One question asks for each rock type that you as an element were part of to tell how that rock formed and what can happen to that rock type. Okay, first of all, three main rock types: sedimentary rock, metamorphic rock, igneous rock. There was some confusion on that in some cases. So from the game board, you can follow the tip of an arrow. If we're looking at how the rock formed, follow the tip of an arrow back to the station before, and follow another arrow back to the station before that, and tell as much of the story as you want or until your arrows run out. So what if we take a look at a metamorphic rock? There's an arrowhead pointing to it here. High temperature and pressure form metamorphic rock. Well, let's see, high temperature and pressure, what came before that? Here's an arrowhead right here. Sedimentary rock. A sedimentary rock was exposed to high temperature and pressure, became a metamorphic rock. And where did the sedimentary rock come from? Well, follow an arrowhead back here. Compaction and cementation. What was compacted and cemented? Follow an arrow back here. Sediments were compacted and cemented to form a sedimentary rock that was exposed to high temperature and pressure and became a metamorphic rock. So you can also work in much the same way, moving forward rather than back. So what could become of this metamorphic rock? And we start here. Where does it go next? Well, it could go to the surface. And what happens to it there? There's an arrow leading here. After a number of stalls at the surface, it could be weathered and eroded. And you can continue on. Now, this assumes that you drew your arrows according to the table. There are a number of cases where liberties were taken, like going directly from metamorphic rock to sedimentary rock. And according to the table, that is not allowed. That's not what is expected to happen in nature. Here's that table, kind of our game rules. And if we look at metamorphic rock, what can happen? It could melt. It could go to the surface. It could be exposed to high temperature and pressure. It could be transformed into a higher grade metamorphic rock. So in the example that we looked at on the game board, yeah, that was one of the choices. That's good. And you can also work the other direction and see how can you get to metamorphic rock. Well, we start at the top. We see metamorphic rock here. High temperature and pressure can form metamorphic rock, and so on. Where do you think rocks are being formed and transformed or changed today? There are so many ways to answer this. One reason is that because plate tectonics is active on Earth, and there are many parts of the rock cycle that are directly related to certain tectonic situations, such as volcanic activity at subduction zones. And the surface of Earth is affected by weathering and erosion. And weathering and erosion create sediments that can form sedimentary rocks. You could write for a long time on this. Another question gets into observed versus inferred parts of the rock cycles. Student answers varied a lot on this, and sometimes events can be both inferred and observed. For example, cooling and hardening can be inferred when magma cools underground and we can't see it, but when the magma reaches Earth's surface, it becomes lava and cools where it can be observed. So things at Earth's surface versus things underground can be a way to distinguish what is observed and what's inferred in the rock cycle. And time can play a role here too. Something that happened a long time ago, we infer. We can't see it directly anymore. And the last question was about Earth systems, and often students didn't write much about Earth systems with respect to the rock cycle. But if you went back, getting the basics down, atmosphere is one of those spheres, or Earth systems and spheres. Okay, so atmosphere is associated with weather, which is involved in weathering and erosion. The hydrosphere also weathers and erodes. We have the biosphere. We have plants that can crack rocks even, breaking them into smaller pieces. And we'll see when we get to glaciers, the cryosphere, that can also do a lot of weathering and especially erosion. So do look back at Earth systems. That is it for now.